Hi, I am Kedar. In this video, we are going to understand rendering deep images and deep compositing. The concept of deep images is based on the paper published on deep shadows by Pixar around year 2000, after which Pixar developed deep shadows. Based on that, few studios started working on deep. Deep compositing started long back in Veta Digital while working on Avatar. Earlier they were working on ODZ format to save the deep data. Along with Veta Digital, ILM, Animal Logic and DreamWorks are also involved in developing deep further. Also won Academy Award for developing deep technology. Currently all major studios are using deep compositing, including ILM, Veta Digital, Animal Logic, MPC, Framestore, etc. Usually the image stores the data of red, green, blue and alpha channels. Deep images has the additional data of depth per pixel. The concept of sorting multiple samples per pixels is transferred from deep shadows to deep images and deep compositing. If there are different objects in a scene, then the deep image stores the additional data of depth per pixel. Then we know where the object is located in compositing. If we render different render layers with deep data, then we can combine them without any holdout or mattes. If there are any change in scene, then we don't need to render all the holdouts, mattes associated with them. Deep is different than Z depth, and it is not a geometric type like Alembic and OBJ, which we use in our compositing software for 3D compositing. We can store deep data in different image formats: ODZ, OpenEXR, DeepZ. This is the old one. Veta started developing and using this in earlier stages. Now we have EXR 2.0, which is also based on ODZ. We have EXR format and DTEX format currently. DTEX is another format which stores deep data developed by Pixar long back. There are a lot of softwares available in which we can render deep output in EXR format. RenderMan was the first renderer to support deep outputs. But now Arnold, Mental Ray, Octane, Maxwell and Redshift are also renders deep data. Nuke started deep compositing far back in version 6.3 to 7, and I am not sure about other compositing softwares to comp in deep. Now let's move on to Maya to understand how we render deep images. So here is a small scene file in which we have different objects. 3 buildings, 1 car and 2 poles, which are separated by some gaps so that we can comp using deep. And I have created different layers in it. Ground separately, car separately, and 2 buildings in one layer, so that we understand how to comp without holdouts or mattes using deep. Once layering is done, then as we discussed, we need to use deep output formats to store deep data along with different file format. You can see here we have DTEX and deep EXR as well in RenderMan. So similarly, if we go to Arnold also supports deep, and here you can see we have a deep EXR image to store deep data through it. Now let's these images and comb these different layers in Nuke. Let's move on to Nuke. So here we have different layers rendered. You can see here all the different layers, and we have a master image in which all the objects are stored. So to load an image in Nuke you can directly drag and drop, but for deep image you can't directly drag and drop. You need a node called deep read. So load deep read now, and we can give the path. So let's load the deep image, and you can see this is not like normal image here. This is a blue node which differentiates from normal image to deep image. So the deep images can be loaded through a deep read node, or else here if you press this D button, then you can have different deep nodes. In this you have a deep read node. So by selecting this also you can load deep images. So now how to see the deep data, whether it's there in it or not. So if you select the image, you don't find any deep here, but as in if you select a deep image, then you can see here we have deep. Once you select deep and select the option deep front and adjust the exposure value to see the deep data here, so you can adjust further to see the distance between the pixels. So further you can adjust. Now let's go back to RGB image. So we can see the deep data using a node called deep 2 points. Let's take deep 2 points and create a camera node and connect it. Now if we go to 3D scene view, we can actually see the deep data. So this is the same image having depth information. So now you can see the distance between different objects. So we have a car here, and poles also, and you can see the car in between these two poles, and you can also see the distance. You can check out this 3D data from different angles. You can adjust the camera and see. From this perspective view, you can go to your camera view. This is how it looks. If you select, this is a point data, and you have options to adjust the size of the points. Here we have used single layer, which is a master layer, and now we understood how to view the deep data. Now let's move on to merging different layers. Here I have loaded different render layers from RenderMan. This is one image with two buildings, and this is another one single building, car, ground, and different poles. To merge all these different layers, we have a node called deep merge. Here we have all different deeps, but this one is deep merge, and you can connect all your images one by one and it automatically adds up. And now if you see, it gives us the final image without any holdout or without any mats. Even if you change the order of it, it remains the same because it's a deep data. It saves the pixel data of the object, and that's why it gives us the proper image output without any holdouts. As we have deep data in our images, so we can actually crop the images along with the z-axis. Like we can crop this pole and we can see the image. So let's have a node. To crop it, we have a deep crop node. As I said, for deep operations we have all deep nodes. So let's take deep crop node. Let's connect it to our deep image. In deep crop we have options here, Z far and Z near, to crop the image. So now you can see I am adjusting the far and near value to crop the image in Z depth. If we adjust further, you can see that the buildings are cropped now from back. So let's adjust the back image and see how the front or near Z near will affect. So now I can crop the pole as well. See, so because this is a single image, the objects are getting cropped and you don't have anything in the back. So we can actually crop building by building, object by object in Z distance. So the same thing can be done in using different layers, which is far better. Let's use the same crop node here, where we have different layers rendered. Now here if we crop, you can actually see that this is the front pole is getting cropped, but the background image is as it is. And you further adjust it, so we are cropping the ground as well as now the car, and now you can see the back pole. So because we have ground here, so that's why when we are cropping it, the ground also gets curled. So the same thing we can do using ground deep merge after the crop. So let's see, we have ground here, we removed it from the merge, and now you can see if we crop, the object is getting cropped, not the ground, because we don't have any ground here. So after this we can actually add another deep merge to add the ground here. Now the crop is before the deep merge, so if we do any operation in it, it will affect only the objects above. So now you can see the pole is not there now, and the car also, because in ground we rendered with shadows, that's why we can see the car shadows on the ground. but if we do separate render layers, then it's very easy to remove the car from the scene using deep crop. This is so easy to work with, and there are different other deep nodes also available, like deep transform and deep reformat, through which we can actually do deep operations. So here we have a deep reformat node through which we can actually reformat the images. It's like same as general reformat, but for deep images. We can actually place any 2D image in our deep comping and in our Z depth. So let's take an image which we have here, copy it and paste. So we need to convert this image to deep first in order to comp it. So if you see, this is a deep image which has deep data, and we have a 2D image also here. And to convert that, let's take node called card 3D. So it's actually converts this image to 3D card. We need to take a camera for this. Let's create a camera and connect it. Now we have connected the image to card 3D. Now you can see the image, and after this we can use a node called deep from image, which actually converts 2D image to a deep image, which can actually store the deep pixel information. So here we can actually merge these two using deep merge, because both are deep images, so we can directly use deep merge. And now we need to adjust the transform of a card 3D to place this object or this 2D card in between our rendered layers without any cut matte or without any roto. So let's adjust the Z value here. So further you adjust, it is going back in Z distance. So let's place it here, and first let's try to place it behind the pole. And we have another node called the deep sample to know the distance of a pixel. Here we have a small dot. Let's take it to the object. Now in the right you can actually see the distance from the camera, the value. It's around 36 for the pole, and here you can see different other values as well for car and building. So here we have somewhere around 36, and here you can actually see distance between these two pixels. You can actually calculate it. So here we have one for the pole and one for the car. So now as we know the value, we can actually directly put this value to our card 3D to place this object in between pole and car. It's looking very small. Let's scale this one so that we can see it properly. Now as you see, this card is placed between the pole and the car. Now you can actually move it without any roto, without any other mats required here. You can directly place it wherever you want. You can further adjust to place the card in depth in z-axis. We can further see now the object, the card is in between the car, because car also has front and back values which are actually different in Z. So now I can actually place this behind the car and before the other pole also. Now you can see it's how easy to adjust without anything. We can adjust this card with the values, as well as we can use deep to pixel, and we can convert the deep data to pixel data through the camera, and then we can see where the card exactly is, and we can also adjust that. Now here you see we have a pole, car and the card. We can take the card further behind, and it's very easy to adjust. Now you can see now the card is between the car and the pole. Now you can see that the card is placed properly. It is placed between car and pole. So now you understood that it's very easy to comp using deep data, and it is very flexible, and you don't have to use any holdouts and any mats here. And now we have few other nodes also available to edit or operate on the deep images. So we have a node called deep recolor, which you can directly take from the tab or from your nodes. So let's select deep recolor. This is actually adjusting the deep, adding the deep data to an image basically. So here in this current tutorial we are directly using the deep images, which has deep data as well as RGBA data, and in few cases we use RGB images separately and we render deep images separately. Then we can combine the both datas together, RGBA data and deep data together in deep recolor node. So now let's add another node to check whether this has deep data, because in this video it doesn't make much sense. But if you have different images rendered, because deep takes a lot of space and render time as well, so it's easier to render deep separately and image separately, and we can combine using deep recolor. Along with these nodes we have deep color correct node as well, which actually does the color correction on deep data or deep images. So let's take deep color correct. It's actually quite similar to the general color correct which we use for image. This is just for deep images. We can combine deep data with 2D images as well. So here we have deep image which are merged together, the images merged together. Now we have a general 2D image. Let's take a normal merge. We can connect a 2D image here, and we can't connect the general merge to the deep, because it has deep data. So we have a node called deep to image, which converts deep data to an image information, 2D image information, and now it's a 2D image. It doesn't have any deep data in it. Now you see, once we merge it, it's a general 2D merging, 2D comping, how we do for normal compositing. It's the same now. Let's adjust this one a bit. So yeah, here you can see both are 2D images. Now you can comp the way you usually do in your 2D compositing. Now if you try to see the deep data using deep samples, you can't. As we discussed earlier, we can use DPXR as well as dtext in Nuke. So here is a dtext image which we loaded through deep read node, and it's again the same data, same image, and you can actually use same set of tools to edit the image as we did with DPXR. So you can see all the points here. You can do the same operations. We can also store the deep image data. So here we have a 2D image which we converted into deep. Now let's see, we have deep data here. If you check the pixels, we have value in it. So we can actually save the same data into an image, deep image, using deep write node. So let's connect it here and put some name here and say write. So once you render this, you are saving the deep image or the data into the EXR format file. So now we have this image, we are attaching or we are merging this deep. Now let's use deep read node to get the image, and this is now deep image EXR. Now we can directly merge it without any card 3D or without any other nodes. Hope working in Nuke with deep images are clear now. Let's move on to our presentation again. Further advancements in deep are selecting objects using EXRID. Here is a paper describing the concept. After some time, I guess we'll be able to pick the objects as well to and do the operations on it, like color correction and other object specific, without any object mats. Also, I found an old interesting article based on deep. In the next few years, we may not be using chroma keying, rather we will be using deep filming. Currently, cameras are available which stores deep data while filming, and we won't be needing any green screen or blue screen for compositing. Instead, we will be using deep data to comp CG elements in live plates. If you want, you can check out the article. Hope this explanation on working with deep images was easy to understand. If you have any further suggestions or queries, please mail me. Thanks for watching.